Good morning, students. Hope you all done your homeworks that I have given to you in the last class. And let me ask something. How many of you have an habit of reading or doing the works or writing your notes? That is the when your teacher is teaching. That means the works you done that day itself. How many of you are habit of like that? You might have that kind of habits, right? You should do like these things day by day, or else you may burden with these things, right? In the exam time or in the last time of submitting the notes, you have heavy loads, and you cannot do that things easier, right? So should you should have an habit of doing these things day by day, right? So I think some of you may done like that, and all of you should do like that, right? So leave it. Today we are going to discuss a new thing, that is, in this chapter we have so far learned so many things, and these things are suppose, and what are the things we learned? Velocity, distance, displacement, acceleration, and so many things, right? So these all things we can write, or we can explain these things by using some simpler methods. By using what? By using graphical methods, we can express the, or we can understand the things much more easier, right? So today we are going to know how the position time or how the distance time graph helps us to know the distance or velocity or something else, right? So we have to learn the graphical representation of motion. There are so many kinds of graphical representation that you may see in TV channels. Suppose there is a cricket match going on, there will be some graphical representation of bowling speed or batman's what else I should say, but here you have the vertical bar graphs show the run rate of team, such that like that there is so many kind of graphical representation. That graphical representation gives much more gives the data that is in a simpler way, right? So here we are going to discuss what the distance time graph first, right? So to describe the motion of an object, we can use line graphs, right? You may see a bar graph, or what else? The pie diagrams. These are all chart graphical representation, right? So here to describe the motion of an object, we use line graph, right? So first of all, we are going to study what? Distance time graph. Okay? We are going to study distance time graph. Okay? So let us look what does it says. The distance time graph says what? The change in position, or the change in position of an object with time. That means what? The change in position of an object with time can be represented on a distance time graph adopting a convenient scale of choice. Right? What do you understand from this? Okay, let me know. Let me talk about this. Distance time graph. We are representing the motion by using line graphs. We already said that, right? So we have the x-axis as well as the coordinate axis, like x-axis, like this is y-axis. You all know this, right? This is x-axis and this is y-axis where the distance is measured and this the x-axis time is measured, right? So this is x dash and this is y dash. You should know this, right? And suppose this distance time graph can give what the idea about our distance time graphs can show various situations that like what an object is in uniform motion or object is in non-uniform motion or object is at rest. All these scenarios can be represented by this distance time graph. So that we have to choose a convenient scale, right? So what is a convenient scale means I will talk it later, right? While we are doing graphs, while we are drawing graphs, I will give you the idea about how we can choose a scale, right? So now look at how we can represent a uniform speed motion, right? So what is mean by uniform speed? How we can say or when we can say the object is at uniform speed? That means if the object travels equal distance in equal interval of time, right? Then the object has a uniform speed, right? So here we have you seen a graph paper? Have you ever seen graph paper? Yeah, you might have seen that. So there may be so many vertical lines and so many horizontal lines, right? So there is some lines like this is 1 unit, this is 2 units, 3 units, 4 units, 5 units and etc. Here also 1 unit, 2 unit, 3 unit, 4 units, etc. So suppose this is the origin 0, this is 1 second, this is 2 second, 3 second, 4 second, 5 second, etc. And here we have in your textbooks one example is given for uniform speed, that is distance time graph of an object moving with a uniform speed, right? So here this 1 unit is taken to be what? 20 seconds. That is what I said scale, right? So if I am drawing a line graph of what a straight line graph or distance time graph of a uniform speed object, we have to choose a scale. That means the x1 unit in x-axis, 1 unit in x-axis implies what? Here you have in your textbooks 1 unit of x-axis implies what? 20 seconds, right? And 1 unit of y-axis implies what? 10 meter or 10 kilometer, right? 10 kilometer. Okay. This is the scale, right? So while we are drawing a graph, we should know what is the scale, what is the scale taken, so that we can able to interpret the graph, right? So here this 1 unit, what the 1 unit of x-axis? Here 20 seconds, that is 40 seconds and 60 seconds, etc. Right? And here 1 unit of y-axis, that means the y-axis 1 unit tells 10 kilometer, 20 kilometers, 30 kilometers, like that. So here it is given that what an object is moving with uniform speed. So what will be the line graph or the distance time graph of uniform speed object? That means at a time 20 seconds it travels. At first it is at rest, right? So this is the origin. Oh, and after 20 seconds the object moves 10 kilometer, and after 1 more after another 20 seconds moves another 10 kilometers. Like that. So, what will be the graph? The graph will be a straight line originating from this object, right? This is a rough figure that I drawn by freehand. So, may have some defects, right? So, what will be the graph such as this is a straight line graph, right? It's a straight line graph. That means as the time increases, the distance also increases. So what we can say, the time and the distance are directly proportional, right? Or the distance and time are directly proportional, right? That means as the time increases, the distance also increases equally, right? That means the object travels equal distance in equal interval of time, right? That is the uniform speed. That the object is said to be in uniform speed, right? So the uniform, this graph, this distance time graph tells the uniform speed object, right? The object is at uniform speed. Okay. So from here we can get the speed of the object, right? We have to know how we can get the speed of this object, or how we can take the word from the graph. We can see from the graph the object moves from the point where O is the starting point, right? And here you have another points that is in your textbook. Suppose this is A and this is B. These points are given, and we can read this time T1 and this time T2, right? 20, 40, 60, 80. Okay. And from the graph, we can calculate the speed of the object, right? How we can calculate? Suppose, what is the speed of the object? Speed is equal to what? The distance s, distance traveled by the time taken, right? So here the distance from here to here is s1 and to here is s2, right? So at an instant, what the time interval t1 to t2, it has the distance s1 to s2, right? So here we have the speed v is equal to what is s? S means this s2 minus s1, right? This is the distance, means s2 minus s1. Okay, divide by what is the time? T2 minus T1, right? That is T2 minus T1. Okay, so this is the what speed of the object at this instant, right? So simply we can get what speed of an object from the graph by knowing what is the slope of this graph. I don't know how many of you learned, or I don't know, you already learned slope of the line in your maths class, right? Have you learned that trigonometric terms like sin theta, cos theta, tan theta? Maybe you know that are things, right? Anyway, we can give this speed as theta and tan theta is equal to what? Slope is equal to tan theta, and tan theta, if you know what is trigonometry or what is Pythagoras or Pythagoras theorem, I think you know that. That is, what is tan theta? Tan theta, suppose this is C, right? Tan theta is opposite side by the base, right? Or the altitude or the perpendicular by base. So what is BC by AC? This is tan theta, right? So this gives the slope, gives the speed. That means when we are drawing distance line graph, the slope of the graph will give speed of the object, right? So this is what we done here, right? BC is what? That is this distance, that is S2 minus S1, right? And AC, what is AC? This distance, that is T2 minus T1, right? This is what we done by the help of this what? Tan theta. Okay, that means slope of distance time graph will give speed of that object, right? Okay, hope you understand this. And you have another table given in your textbooks, that is distance traveled by a car at regular interval of time. We have to draw these in a graph that I will give you later, right? And here is one more graph given to you, that is a distance time graph of a car moving with a non-uniform speed. This is the distance time graph of uniform motion, right? The car is moving uniformly here, right? That means the object travels equal distance in equal interval of time. So this is the distance time graph of a uniform and distance time graph of an object moving uniform speed. Okay, so that's so what we have discussed so far. What we have discussed so far, we only discussed what the things, that graphs, that is distance time graph. What is distance time graph? The distance time graph shows what the changing position of an object with the time, right? And we are drawing distance in y-axis and time taken is in x-axis, and we can draw the object. If the object is in uniform motion, the graph will be a straight line originating from origin, right? So if the graph is a straight line from origin, means the object is at rest first, right? If the object is having some speed first, it may be, the line graph may originate from here and somewhere else, right? And the thing is, you have to know what the object is at uniform motion, then the graph will be a straight line. Okay, and this table 8.2 gives the distance traveled by a car at regular interval of time, and it is what the time is in seconds are given, and the distance in meters also given. You can read that, or you see that. I will give the table here, right? This time, distance. Okay. That is time in seconds, distance in meters. Okay. And 0 second, 0 second, the distance is 0. That means at first the object is at rest, right? And 2 seconds it travels 1 meter, and 4 seconds what it will become 4 and 5, 2, 4, 6, right? The time interval changes by 2, right? 6 seconds, 6 seconds, 6, it's 9, right? Sorry. And in 8 seconds, it is what? The distance covered is 16, right? So, from here you can see the distance covered by the object or by the car is not uniform or not equal distance, right? Here the difference is what? 3, and here difference is 5. Here what? 7, right? So this is the interval of time. The time interval is always 2, right? But the distance traveled may change, right? So this is the in the case of a non-uniform motion, right? This is a non-uniform motion. So how would be the graph for this? How could be the graph for this? Ensure that the graph must not be a straight line, right? So what is the difference? What will be the difference? So I just roughly draw the graph. Okay. This is x-axis. Here we take time, and this is y-axis. Here we take distance s. Right? This is origin. This is x dash. And this is y dash. Right? So at here we have scale. What is the scale? At one unit it is 2 seconds, and for another 4 seconds, 6 seconds, 8 seconds, 10 seconds, like that. And here we can take the distance as 5, 10, 15, 20, 25, like that. So what is the scale? In x-axis 1 unit says 2 seconds, right? And in y-axis 1 unit says 5 kilometers, so 5 meters, right? So what is the scale? Scale x-axis 1 unit gives what? 2 seconds, and y-axis 1 unit gives what? 5 meters, right? Okay. You should remember what is scale, right? So here in 0 second the position is here, okay, and then after 2 seconds, the distance is somewhat here. In your graph paper there is 1, 2, 3, 4, 5, 6, 9, 8, 9, 10 lines will be there. Like that, 10 horizontal and 10 vertical lines are there. So each one will be here. It's 5 units. So 5 by 10 gives 0.5. Each line gives 0.5 meter distance, right? So there may be while doing exact graph, we have to know that all things. So here we are doing the rough graph. Okay. So suppose where does where one maybe where is the position of 1 meter? This is 5 and the exact half is 2.5, and one may be suppose here, right? So in 2 seconds the object travel 1 meter. Okay. Then if we take the for doing this, we can take the scale. We can change the scale. If it is what? If it is the x-axis, we can change the scale y-axis. If it is 5 meter, 1 unit maybe 1, 2, 3, 4, 5. This will be easier to know how the can be known, right? So in 2 seconds it travels 1 meter. So and in 4 seconds what will be the distance? 4 seconds 4 meter, right? So in 4 seconds it is in 4 meter, right? Do you have any doubt? You have any doubt for taking this scale? I just draw this scale for simplicity or to know the how the graph exactly comes, right? If it is 5, the unit is the y-axis 5, we take 1 unit as 5. We have some difficulties while drawing this because here the distance in meters are 1, 4, 9, 16, etc. So in 4 seconds it travels at 4 meter. So if we take this with a small scale, we have to draw a long line in y-axis. So there is the what 36 distance in meters. 36. It takes 36, right? So we have to draw. If we are taking this scale, we have to draw a long line. So that in your textbooks they take 5 as 1 unit, right? Hope you understand. So this I am changing this for only for say showing this graph may be like this, right? And in 66 seconds it may what 9 maybe what this 6 7 8 suppose somewhere else in here, right? So what in 6 seconds it may be here, right? So this graph will move like this, right? So here you have given in your textbooks the graph is going like that, like a curve, So this only says but non-uniform speed. If an object is in uniform speed, the graph will not be a straight line. Okay, the graph may be like this. That the graph says only only that things. So by doing this, you have to keep in mind how we can take the scale. So here it is impossible to take the scale as 1, 2, 3, 4. Right? Why we cannot take this as 1, 2, 3? If we are taking 1, 2, 3, the unit distance, that means in y-axis we are plotting distance, right? So if we are taking 1 unit as 1 meter, we have to take a long, that means 36 point. That means here we have long y-axis. We have to take long y-axis. So that is because we are taking, or the textbook here you have given, that is 1 unit is 5 meter, right? Hope you understand. And that's all about distance time graph, right? I will give you the distance time graph of what this example in a graph paper. I will draw the time and distance in an exact graph paper and I will send it to you, right? And today we are wind-upping and hope you understand how we can draw a distance time graph, and I will bring you graph paper and I will show how to draw this distance time graph in actual graph paper, right? So that you can understand more, or you will be able to know how to draw the graph by giving the data that is given in your textbooks, or maybe another data, right? So today we are winding and hope you all understand what we have learned today. Only small things that we have learned today, right? The distance time graph, how it works, or how the object travels in uniform speed, and how the graph may be, or how the graph becomes in uniform motion or having uniform speed and non-uniform speed, and how we can get the speed of an object from these graphs. That means the slope will give the speed of the object. The slope of distance time graph will give the speed of object, right? So I am winding today, and we can see in the next video. Till then, goodbye and thank you.